Задержались. В общем, добрый день, меня зовут Никита Тараканов.
So my name is Nikita. I'm sorry if you came for another presentation. Something happened to me because a vice president actually something there. I couldn't come. I could come but make a presentation, but they will kind of punish me for that. So I made a new presentation, and this presentation is a compilation of two from my research on the maintenance of memory corruption in Windows Core and my colleague's presentation from Advanced Threat Research Team on SMI handlers and vulnerabilities. And
Если рассматривать
if we consider
компрометацию, да, в
compromising,
основном можно увидеть, что компрометация идет
so we can see that first it's drive-by download attack, and then
и чтобы для закрепления на системе ставить там ядерный рootkit. Но на самом деле в последние года два появляются исследования, там парни
over
из
the last
мои коллеги из Advanced Research Team,
my
много
colleagues.
исследований по атаке на SMM.
So many research on SMM attacks, and
Соответственно, сначала
first
расскажу, как
I'll tell you how the exploit happens and how the
ядра, то есть
core
сейчас, как вы
gets
знаете,
compromised.
происходит в
So
основном
as you know,
такой софт, как флешплеер,
the
браузер,
Flash Player browser reader.
Ну, так как это user mode программа, они исполняются на
So as the programs would be executed,
кольце, плюс еще и они в большинстве из них реализованы
most of them sandboxes are made. So in order to you need to raise. And raising privileges, so attacking the core from the sandboxes, is a good move. And for instance, in 2013-14, Pwn2Own E and Chrome was hacked through the core vulnerability in the core, but the core is not the privileged mode because SMM exists, and we can go on and keep talking about manageability agent minus third ring, and manageability engine is out of scope of our presentation. So I'll tell you about the attacks from the third ring to the ring 3 to ring 0. I'm not talking about architectural and binary vulnerabilities, and let's talk at the memory corruption. Three types here. Stack-based corruption, but it's rare in the core. So dynamic memory pool overflow and controlling the address by the attacker. So stack-based buffer overflow is out of range. Nothing to tell because it's stack. Exploit is difficult. Arbitrary memory corruption, so no story either, because I better tell you about the pool overflow with different techniques that give you arbitrary memory corruption and a transformation of overflow for controlled address. And exploit mitigation that's now working in the core. I told you about the stack canary, the pool checks. Then there's kernel ISLR, SMEP, and SMAP that works with Broadwell, but in Windows it's not realized, and I don't know how they're going to do it because they need to redo output manager. And in Linux, a vanilla kernel doesn't have it yet. So the goal for the attacker is to bypass all the checks of metadata and bypass all those three protection tools.
Если рассматривать техники
So
эксплуатации
if we look
full
at the
overflow,
exploit
то
techniques for
они,
overflow,
я их разделяю на
I
на три категории.
have
То есть
three
первая
categories
категория
for
это
them.
атака на сами
First is
метаданные,
the
то
metadata
есть
attack,
на
that is
структуру чанк и так далее и тому
chunk
подобное.
structure,
Про эти техники вы можете
and
почитать.
you can read
Есть такой
about
исследователь
the
Такшимант, он
techniques
делал несколько докладов по
from
этим
a
темам, и
researcher.
я
I
считаю,
didn't
что
get the
это один
name,
из
and
самых
I
лучших
believe
исследований.
that one of the best articles on
Далее
it.
атаки
Then
на
attacks
объектные метаданные и
for
атаки
object
на
metadata
самообъектные, на
and the
объектные
object
метаданные. Ну, я это
metadata.
называю DKOHM,
I call it
значит, Time Kernel Object Header
DKOHM,
Manipulation. И Object Type Confusion — это, в принципе,
an
комбинация
object
из
type
манипуляции хедером
confusion
и манипуляции с самим объектом.
of header and the object.
Чтобы вообще Full Overflow — это такая
So
громадная
pool
тема. Если бы я
overflow
покрывал
is such a
все
huge
эти
topic.
техники, то это
If I
заняло бы, я думаю,
tried
около 2
to
часов.
describe all of
Вот,
them,
соответственно, я
I
не
would
буду
take
рассказывать
at
про
least
атаку
2
на
hours.
метаданные пулы, я расскажу
So
про
I will
атаки
not talk
на
about the pool
метаданные
metadata, but
объекты.
the object.
Соответственно, когда вы
When you
используете какие-то
use
API,
some
там,
APIs
создаете таймер,
and
event,
create a timer,
процесс,
event,
thread,
process, thread,
составив
mutex,
ядерный объект
so you
в
create a
динамической
core
памяти.
object in
И
dynamic memory,
layout
and
выглядит
layout looks
следующим. Сначала идет
like
pull
that.
header, который,
First pull header,
собственно, метаданные пула, который описывает chunk, то есть какой он длины и так далее.
that describes a
Далее
chunk,
идут опциональные
then optional
хедеры, в
headers,
зависимости от типа объекта их
and
динамического количества.
dynamic
Дальше
number,
object header, и
then
после
object
object
header,
собственно, сам
and then
объект.
the object.
В object header это
In the
layout
object
из
header, it's a layout of
с Windows 7.
Windows
Windows 7
7.
layout был немножечко другой.
Was different,
Но смысл тут в
but
следующем, что
the idea
header
is
содержит
that the
очень
header
интересное поле
contains very
с точки зрения
interesting
атакующего,
field
это type index.
for the attacker, is
Это
type index.
индекс
That's index
элемента,
of an
который,
element
собственно,
that
указатель
that's pointing
на структуру object type, которая,
for the
собственно,
object
описывает
type
тип
that
объекта.
describes the type.
И эти указатели, они
And
хранятся в
these
определенной
pointers
таблице
are
указателей,
stored
которая
in a
называется
special chart table.
type index table. И до Windows
And until Windows 8.1, the layout looked this way. So the elements started with the third one. The first element was 0, the second was a constant, and then real pointers.
Сама структура object type
The object type structure
интересную структуру type info,
has type
которая
info
хранит
that keeps
указатели на функции.
function pointers.
Ну, это callback'и, на самом деле.
That's callbacks.
То есть, когда, например, какой-то объект закрывается, у него
When
есть
an
соответствующий
object
обработчик на
closes,
закрытие.
so it has a special processing.
Далеко не у всех
Total
типов
8.
объектов есть
It's not
какие-то
all
процедуры
objects
на,
that have
допустим,
some
dump, на
procedures
close и так
for
далее.
close, dump, and so on.
То есть в зависимости от типа
So
объекта, они
depending
будут
on the
инициализированы либо
object,
нулем, либо
they will be either
указателем на
0
функцию.
or pointer to a function.
Соответственно, как выглядит как бы
So
связь?
how will the
Соответственно,
connection
у нас
look like?
type index указывает на какой-то
Type
элемент в этой
index
таблице,
points at an
а
element,
object type
and the object
содержит
type contains
список указателей
the
на
list of
функции.
pointers to function.
Соответственно, идея была следующая.
The idea was,
элементы начинаются с
well,
третьего,
if the
а
elements
первый и
start
второй,
with the
ну,
third, but
первый
the
это ноль, а
first
второй
is
это
0,
робот, то мы
and
можем при выполнении
second,
изменить type index
well, so we can
вот
change
с, как бы,
the
легального
type
в
index
этот,
from legal to
есть,
this
например, ноль,
inexisting, like 0 or 1.
Да, вот, соответственно, причем на 64-битной системе
For the 64-bit system,
константа, она
the
расширена
constant
нулями, и
is
получается следующее, что если
And
у нас
what we get is so this address is in the inside the core, and to create an object, a fake object type, you have to have the address, and so then it's 2 gigabytes, and not always possible. The 64-bit system, this address is located in user mode, so you can easily allocate the memory and create this object type. easily. And so graphically it looks like this. We change the type index when it's overflowed at 0 level, overflows. Then object manager thinks that this object is 0 or 1, which don't exist. And these addresses create fate object type for these addresses. So with the indication of with the indicators of the functions for the ownership of this code. Windows 8.1, so they changed, they made some changes after they read my slides. This address, this array is filled in, so then user mode, you cannot allocate it from the user mode. So it's locked. And very simple things. You can change time index for the non-existent time index. I thought that it's possible to type index can be from A to B, changed from A to B, and type E to type B. And so this approach, with the help of the overflow of dynamic memory, we change the type of an object. And that so we get some results. Then for the object manager, because we changed the type index, so it will see different type object and file and will treat it. So before overflow, you had so type object type file, and then after the type index, so it's class E. And there'll be some changes to some functions with the object that can give you primitives of the overflow of memory at a certain address. That's how can we use it after overflow. The object manager thinks that's a different object of a different type, a type confusion, and can perform certain systems challenges, and then the core will turn to these objects. And since the objects are nested into the structure, so there are pointers to the structure, and so this leads to the overflow, to re-recording under the of the concrete address. And then I was telling you, for example, play out. That's what these functions look like for class type 3 object. So as you see, so then at the dump, no functions, but for closure, for removal, and so they have functions. For example, so type file, file type. So there is a security, a parse security procedure. And so if we have an event object, and then you the system's function security information, you again before overflow, so the core will generate default object matter. But after overflow, it will get the secure procedure for file. So then another function will be called, and that will lead to very interesting things for this subject. And if you do the dump, then for many objects, so the security hot store is default object method. It doesn't do any manipulations with these with the object data, but IB set security object and TIOP get set security object that the attacking can actually intercept the implementation. So the file object is quite big. It's quite complex, and it's so that there is something else inside. So then device object. So there is the driver object. So there's and the driver object has another callback functions list, and so there is 3 different things are inside, nested inside, and you can see that object file,
второе разыменование,
and
там, как
then
видите, идет jump.
you can see then there is a
То
jump.
есть, если вы перезаписали этот
If
объект,
you
контролируете задний
rewrite
контур,
this object,
разыменование,
so then you do jump.
идет перехват.
So you intercept the implementation.
По идее, этот способ
And
уже
so this
хватает для компрометации. То есть
so
вы
this
контролируете
this
связь
method is
и-
sufficient for compromising.
Но
You control the IP
смысл в том,
address,
что
but the point is that
надо выстраивать
you
эту
need to
цепочку, чтобы
build this, send the T connected to the chain. You need to do that, and it's quite challenging to do sometimes.
Я показал просто структуру.
That's the structure.
Да, соответственно, можно использовать
So you can use
все эти функции.
all
Ну, я
functions
имею в виду, с помощью определенных
with the help of some systems calls. You can just call these functions. You can call them. And the security procedure, you can trigger, so then you get security information. Then you can trigger the call of read, close handle. And so then there's a cross-delete procedure for all object types. And
На Windows 8.1 там, по-моему, 28.
minus 8.1, so there are 28 classes and about 56 functions.
Там идет
A huge amount of different execution flows, and there's an overflow of memory until the interception of execution.
другие процедуры, они не так,
Other procedures, they are less.
они инициализированы не у многих.
They are not initialized in many classes, and they are of no interest to us.
Вот. Далее
Then you can use not only header, but the object proper.
так как объекты это у них
Because
есть,
the objects have interfaces, and there is a constructor, anti-create file, and
handle или
close handle, anti-close are the triggers of the calls of destructor, and the close procedures,
название объекта.
and the setter is anti-set information.
Есть
So then there are specific systems calls for different objects like event and etc. type objects.
До того, как я написал первый протест, до первого теста моей идеи, я думал,
Before I
что
tested
очень
my
хорошая
idea
идея, так
for
как
the first
я
time,
просто могу
I
изменять
thought I could
объект,
change the object
B и
type A object to type B object and to treat it as type A
К
object.
сожалению,
But unfortunately, that assumption was wrong, and so when you do the calls like anti-information working factor, so there is a call
проверяет как бы
that checks the mask of the class,
И, к
and
сожалению, у многих
not many
классов
classes
эта маска, она
this mask coincides.
Вы можете видеть,
Then
у
mask doesn't coincide.
класса Windows Station и у класса Directory
So
access
Windows
mask,
Station directory access mask is different.
соответственно, нельзя
That is why you cannot
Windows Station
to overflow and to make it into directory and to treat it as directory. You can do that. You cannot do that. There's the functions because of the access mask is wrong, so the core will not return the object. But the process access mask can treat the same mask. They coincide.
Ну да, вот у секции и у работы одинаковые. То есть вы можете
So then the section object you can change job and act it as class job treatment.
Далее
Then
при переполнении динамической
when
памяти
the dynamic memory overflow to intercept the execution, you can read memory using arbitrary memory. So then class symbolic link object, the object looks like a call string. You can overflow.
затереть указатель, затереть длину и обращаясь к этому
You
объекту.
can remove the length, and you can treat this object with the help of symbolic link object. You can call it like that, and you can read up to 65,000 bytes on any address. So this object and this system of calls is good for reading memory. And there are many primitives because on the Windows 8, so there are many systemic calls, 200 interfaces. For example, this interface gives the primitive that you can read up to 37 times different memory quadron. Keyword. So worker factor object gives so you can read up to 8 bytes at a certain address. So worker factor object is a very good object for operation because this class, this object gives the primitive for both reading memory and and at the same time it gives you a primitive to rewrite at any address with controlled values. You can see how it's done. Then we have all primitives for reading, overwrite, so KSLR bypass. So then we have overwrite at the controlled address, and then we can redirect the execution to another node. So actually these primitives are enough to bypass any protection, any security, SAP, KSL, R, etc.
Да, в общем, я надеюсь, тут не знаю, да, что такое system management mode.
You know what system management mode, SMM, you know, it's a special mode of the processor, and so how it appeared. As far as I remember, originally it was the tuning mode, but then later different companies like Dell, IBM, so they learned that Intel has this mode, and they requested an access to it. And then this mode started to use it for notebooks to switch off the notebook if it starts heating, etc. To turn it off. So you can system management interact. You can just get into it and protected from software and device access. So it's protected. So there's certainly a certain pin, but you can do it using software, and so then the code is executed in a special memory, system management RAM, a special memory, and it's located, it's protected from the core, and the processor should go back and the return system management. Then so it looks like there is MSR, so field base that identifies the physical address and the code in SMRAM. So there is memory to save the state before SMI and the code SMI handler. Then SMI handler is a big subject matter. It has roots, not root, chains, and all executed link by link along the line. And I don't want to go in greater depth. And this mode is very special, and so you cannot stop it. There's no paging when it's being executed. No memory access, and then there are some technical specifications for the so EIP state 0.0888900. And then SMI, you can trigger it with the help of software, with the help of the entry of B2 port. So why was it done? To somehow give a possibility to the developers to make an update, to make updates. So there's a backdoor for updates opportunity. And so this presentation shows us this chipsec. It's good. It's a good framework, and so there are many Python scripts. And this framework, I'm a developer too. We're developing for anyone. It's an open source project to test your system, whether your BIOS contain certain vulnerabilities or not. And we have a lot of tests, different tests for different vulnerabilities. Let me talk about famous attacks against SMM. So the first attack, the simplest attack at SMM, protection of the region of SMM is programmed by certain registers. And unfortunately, so the BIOS problems and security problems is that Intel is a head company, so we do the BIOSes and we do the technology, and the company that develops their own versions of BIOS, so HP, IBM, Dell, they unfortunately they're not using the protection mechanisms, and they make serious mistakes. I don't remember until just recently SMRAM was not protected during rewrite, and that's what it was. And to check whether your system is open in SMRAM, you can check it with the help of a certain script from chipsec, and to make sure it works. Then this research is very interesting, and goes back to 2008. And so Duflot, a researcher, he found that SMRAM can be cached using certain methods, and cache is not protected, and thus you can rewrite SMRAM, the code in SMRAM, and trigger SMI and execute in SMM mode the code in SMM mode, which will be. This vulnerability was found in Invisible Things Slab, and this is a shame for Intel. It was a shame for Intel. So because they use just the call of the year, not from SMRAM memory. They just call a function call that is in the space of core. So then the attacker can change the code at this address and execute his code with the rights of in the SMM mode. And sometimes even at one SMI, so up to 14 vulnerabilities they found. So everything is not good. So then it's not safe. The system is not secure. And there are mistakes when they call quotes from legacy memory. So this is physical memory. And then you see, not everything is not good. So this is the code. So it's a thing slap. So they just call the PI indicator from PI memory and from the core, not SM, not protected. By the way, against such vulnerabilities, when they just call function, so when they call code not from SMM memory, Intel introduced a new technology, which is an analog of SMPP for SMM. So if a code is executed in SMM, and then there is a jump into the memory, which is SMRAR, so there is a fault. But if you can check it with chipsec, and so they just don't include this option because they don't have this option. It's just the graphical representation. So then check exception is run on this machine.
То есть до того, как мои коллеги сделали это
before my
исследование,
colleagues did this
не
research,
было
there
именно
hadn't been
эксплуатации
any
повреждения памяти. То
operation
есть
of
были эксплуатации,
memory
когда из
damage.
какими-то
So there were
манипуляциями
some
просто
manipulations,
перезаписывалась
so
память
the memory was
SMRAM,
written, the SMRAM
были
memory wasn't
прыжки
written
просто
physically, there were
в
jumps there
незащищенную память.
into unprotected memory. But
Если посмотреть как
if
бы
you look
calling
at
convention, как
calling,
должны,
calling
что
convention,
должен содержать регистр,
what the register
примерно это
should
выглядит так.
contain, it looks like this.
То есть в
And
RCX
RCX,
это функция, но на самом деле это
it's a
ID,
function, it's an
RBX
ID.
это pointer на
RBX
данные,
is a pointer,
и смысл такой,
and the
что
idea is that
в определенном регистре
that in certain
указывается код
register
ошибки,
they
например.
show the code of error, error code,
И, к сожалению,
and
очень много
many
вирусов, они
biases
просто
they
слепо не проверяют.
they don't
Естественно,
check them whether it's
ну, эта память
this
находится в SMRAM
so
или нет.
this is in the SMRAM,
Соответственно,
this memory or not.
поставив поинтер, который
And then
указывает
if you put the pointer that points to SMRAM, so you can rewrite it with a certain value, this memory in SMRAM.
Но проблема тут заключается в
But
том,
the,
что,
but
во-первых,
the layout of SMRAM is not known,
вендора к вендору
and the vendors, different vendors,
достаточно специфично.
very specific. You cannot rewrite it to some certain indicator because we don't know so where this is located.
Есть
And but there is another
очень хороший способ.
very good method.
В SMRAM
In SMRAM, SMRAM contains information concerning the boundaries of this range. And if the value that is overwritten written in the memory, if it's good for a writing of the range, then exploit is ready. Because we can easily rewrite, overwrite the back range, and thus SMM will think that SMRAM is in another range. So we do the relocation into the unprotected memory, and thus we can write the code in SMRAM, which will be in core memory, and execute your code. So there are some subtleties, but the idea is what I've told you about. So then there is a shift. I have a demo. It's not very good, but I'll try to play it for you.
Да. Собственно, здесь просто консоль показывается и
And there's a
запуск
console that is shown,
чипсета.
and when you launch chipsec, it checks tunings, settings for SMRAM protection, and then they launch exploit, and this is it. And then the printf that the code in SMM is executed. That's it.
По-моему, в 1.7 последней
So I think
версии
at
exploit
1.7 this
присутствует. Я
exploit is
точно не могу
there. I
гарантировать.
think it's, I don't
Просто у
guarantee,
меня
but I think it's
смешано
there.
публичные версии,
There's a
приватные.
public and private versions mixed up. And,
Да, да, собственно, да. Вот. Может, видишь, you already have full access to SMM.
so you have this access to SMM.
Да. Вот. Как все происходит, то есть, ну
So
да, просто
that's how
идет
it goes.
релокация
So there's
SMM.
a relocation of SMRAM
Да, ускоряем
occurs.
процесс.
So we fool the processor.
Таких техник, как в ядре, когда мы просто
So such techniques like in the corner when we add with a point and an indicator.
В атаках на SMM
So then
так
SMM
просто
attacks,
не
it
получится.
can't do that.
Приходится изменять
You
диапазон.
have to change the range.
Но с другой стороны, если
But on the other hand,
таргетированная атака,
if you
например,
target
определенный
your attack
BIOS,
is
определенного
against the
вендора,
bias of a
можно
certain
сделать,
vendor,
и более
then
точный
against
exploit.
certain you can make a more intricate exploit.
В принципе,
That's about it. Thank you.
какие-то вопросы, пожелания и так далее. Да? Я не ругал, я просто отображаю реальность. Так я под биосом имею в виду UFI.
I think it's API. When I say about BIOS, I think it's API. So I help BIOS vendors to correct vulnerabilities because the BIOS structure is quite complicated, and to remove vulnerabilities takes a lot of time, just a lot of time. So years sometimes. V3 vulnerability. You will have heard about it. So they made a presentation at the end of December at CCC. Presentation. Intel launched the patch, but it didn't work, and then all vendors were vulnerable. All were, and even now this patch is not. It will be released by Intel, and when all the vendors will have to use patches. But even after a patch has been released, I don't know the people who can install BIOS update. So there are many systems are not patched and vulnerable. And Kit SMM, they are pretty well protected from the viewpoint of viability, so they're much better than core systems. Any more questions? And what about, have you ever come across rootkit using these techniques, rootkits, or it's always a constant? I do not work for NSA, I don't know. In the wild, I haven't seen anything in the wild. In the wild, so maybe in 5 years' time, maybe we'll learn that they exist now. So there is a 5-year delay. So eventually we'll learn that they exist.
So the idea is that it's more difficult to identify them.
Окей, мы релоцируем, соответственно,
Yeah.
RAM, да? Соответственно, грубо говоря, мы ставим диапазон, мы
So we shall set the range and probably increase,
покрывая таким образом кусок
covering
кернельной памяти. То есть
some kernel memory where we had the
управление мы туда
pre-root, and
передаем
then
через,
we
скажем
pass
так,
the control
предыдущего поколения,
through
скажем
some
так,
previous generation.
Так как
Yeah,
SMI
as
киллеры, они завязаны в двухчастный список, и там
the
можно
SMI
сделать
handlers are in the
код
list,
исполнить, да.
so you can
то есть
have
это
your
как раз на
code
уровне
executed.
SNI метод, который
That
вот,
Да,
that
всё.
yes, that yes. Это вот да-да, это вот да-да.
Спасибо.
Thank you.